Hello everyone, welcome back to H3 Platform YouTube channel. Today we're going to show you the graphical user interface of our brand new Falcon 5208 NVMe MR-IOV solution. So before doing that, I'm going to introduce you more about Falcon 5208. So what is Falcon 5208? It is a NVMe MR-IOV solution, so it has multi-host connectivity and it has NVMe SRLV enabled. And it is also a composable SSD solution, so you can assign or unassign the virtual functions from the host machine. You can also attach the namespace. And for SSD management, you can create or delete the virtual functions, or create and delete your namespaces, or erase and format your SSDs. So let's take a look at the architecture. Here we have a NVMe chassis. All the physical functions of your SSD are controlled by the NVMe chassis, and it is connected to multiple host machines with the external mini SSD cables. You can connect up to 8 hosts per chassis. And here is the virtual machines. You can create whatever virtual machines on your hosts. And these virtual machines could access any SSDs from the chassis. So again, this is a pool of virtualized SSDs, and all the management commands are from the BMC. Users can configure the SSDs without interrupting your host applications. What's good about it is that you also get a unified management interface, and that will reduce your management complexity. And let's talk a little bit more about SRLV. So in SRLV, there are 3 terms you must know, which are the physical function, the virtual function, and the namespace. So the physical function is pretty much the SSD itself. So it has the complete PCIe function. And the virtual function is more of a lightweight PCIe device. When you assign the virtual functions to the host, it creates an I/O path. And namespace is the actual resource. So it is a logical block of the flash memory, sort of like a partition, but slightly different. So what we have to do is that we want to assign the virtual functions to the host so that when a host recognizes this device, it will see how much memory resource it has. To allocate the resource to our virtual functions, we want to associate a namespace to it. So this action is called attach. So we want to attach a namespace to our virtual functions so that it looks like an actual device to the host machines. All right. So how we manage the resource allocation on Falcon 5208 is that we pre-assign all the virtual functions to the host, so the virtual function stays there, and it provides a I/O path to all the SSDs. So basically, we assign all the virtual functions from different SSDs to the hosts. And then what we can do is that we create any namespaces and we find the virtual functions that is associated to the host, and we attach it to it so that the host gets the resource. Here is an example. So if we want to add 300 gigabytes of storage to our host 1, what we want to do is that select an SSD first. So we want to allocate this 300 gigabyte from our SSD number 1. And then we want to find the virtual functions on host 1 that is associated to our SSD number 1. And it would be virtual function 1-1 in this case. All right. Now let's create a namespace on SSD 1 and set the capacity to 300 gigabytes. There you go. And then we can attach this namespace to our virtual function 1-1 so that our host 1 gets 300 gigabytes. So that's basically how we do it. And Next, we'll move on to our graphical user interface to show you what you can do on the interface to achieve all these results. As you can see on the screen, we are at the login page of the graphical user interface. So let me log into it using the administrator account. Okay. Oops. All right. So we are now at the overview page of the graphical user interface. As you can see, we have the device list. So you can see that we have 1, 2, 3, 4, 5, 6, 7, 8 NVMe SSDs installed in the system. And we have done some configurations beforehand. So we have created 100 GB of namespace under every SSD just for testing. Okay, and here is the notification board. So basically what you can do here is you can see the logs of the system. So if there is any error log pop up, this will turn to another number, for example 1 or 2. And there are 4 warnings, there are 90 information logs, and 6 logging activities. So if you click on the icon right here, you can see the list. So we currently have no errors and 4 warnings, and we have a bunch of informations and 6 loggings. And here is the thermal information. So it provides the temperature of our backboard, the PCIe board, and the average temperature of the devices, so which are our SSDs, and the temperature of the PCI switch itself. So under that is the system profile. You can find all the detailed information about this particular machine, including its model name, the Falcon 5208, and serial number, MAC address, the firmware version, and system uptime, and so on, and the IP address. And at the end, there is a PCIe throughput graph. So we haven't connected this machine to any host yet, so there is no throughput displayed, but if you do, it will show. And you can actually select the time period you want to display, and you can select the traffic type. You can have ingress only or egress only or some of both. And you can even sort the SSDs. You can find only the available ones. You can find only the full ones or the one with errors. And let's go on to our next page, which is the resource management. So first thing you'll see when you enter the resource management is the host list. We have created 5 host ports, and normally it would be two PCIe Gen 4 by 16 ports, but we have bifurcated the first one. We have configured the first host port H1 into 4 PCIe Gen 4 by 4 ports. So you can see that it's H1.1, H1.0, 0.1, 0.2, and 0.3. And we didn't do anything with the host port number 2, so it stays at Gen 4 by 16. And you can see how many virtual functions are assigned to each host port. So we have 5 here, 7 here, 8, and 15 to the last one. Okay, so if you click onto the drop down icon right here, you'll see the list of virtual functions that is assigned to this host port. And since we haven't connected to any host, it wouldn't show any link information. Again, right here. So it shows no connection all the way. That's pretty much it about the host information. So let's move on to the SSDs. So here is the list of SSD. So we have 8 of them, and it shows you how many VFs have been used and how many namespace have been created under each SSDs. And I believe we have enabled 7 virtual functions under every SSDs for this particular system. So, and we have used 4 out of 7 for the first one and 5 out of 7 for the second SSDs. And you can see how many NVMe capacities are used. By used, it means that we have created this amount of namespace. I mean, we have created 100 gigabytes of namespace under each SSD. And for SSD number 6, we have used up everything, and about a terabyte for the last 2 SSDs. Okay, if you click on the icon at the end right here, you can enter the management page of each SSDs. So let's take a look at the first one. So here is the detail. Here is the information of this SSDs. You can find the model name right here. You can find its serial number and the capacity and how much is being used, how many namespaces have been created, and how many VFs are assigned, the temperature of the device, and the health status. Okay, and on the right hand side of it displays more detailed information, so including firmware version of this SSDs and the subsystem ID. So we have the Samsung PM1735 SSD, so it shows Samsung Electronics. Identifier and a lot of informations about these SSDs that we normally wouldn't need unless you're like a system administrator that you have to keep track of all these informations. You can find all of them here. And so let's scroll down to the virtual function assignment information. So again, you'll find a list of hosts, and you will find how many VFs are assigned to the host ports. But this time, it only includes the information about this particular SSD. So the SSD on slot 1. So we have assigned 1 virtual functions from SSD 1 to our host port 1.2, and 1 to 1.3, and 2 to our host port number 2. And you'll see that we have attached a namespace right here. Okay, and if you click on the VF management, you will enter the actual VF management page where you can do the configurations. So at the top of it, you'll find the basic informations, the VF assignment informations. So we have assigned 4 VFs, and there are 3 left, and we have 5 hosts, and the VFs are assigned to 3 of them. So we can find that 2 of them doesn't get any virtual functions from this SSDs. And on the right hand side, you'll find the list of host machines, host ports you have. So we have 5, as you can see. If we want to assign virtual functions to it, we simply click on the plus icon right here. Assign virtual functions 1 to H1.0. Yes. Alright, the virtual function has been successfully assigned to host, and you see that it turns into 1 from 0, and our virtual function number 1 is assigned to our host 1.0, And again, there's no connection because we didn't actually connect any host machine to this host port. But if you do, your host machine should get this virtual function. If we want to assign another virtual function right here, it will automatically assign the first available virtual function, which for now is our virtual function number 2, to our second host. All right. Okay. And it is also quite simple to unassign it. So you just click on the unassign button right here. Press yes to confirm. The host system that does not support hotplug may crash. Since we don't have any host system right now, we can just safely click yes to unassign the virtual function. Alright, now it's gone. Our virtual function number 2 is back to FreeVF again. Let's go back to the information page. If you click on the list here, you will find that our virtual function 1 is attached here, but it is assigned, but we haven't attached any namespace, so the capacity remains 0. And there's no virtual function to our second host. And here is the namespace information. You can format the namespace, modify the NMIC, which I'll talk about it later. But let's create a namespace first. So we'll create a 1 terabyte namespace. We'll keep it private. This is the NMIC. So if you keep it private, you can only attach the namespace to 1 virtual functions at a time. But if you create a shared namespace, you can attach it to multiple virtual functions. So let's create a private namespace for now. All right. So let's say we want to attach it to our first host machine. So that's our virtual function number 1. We click on not attached. So we select this one right here. That's the one we want to attach it to. And since it's private, you wouldn't be able to double select any of these. So you can only assign it to 1 at a time. Let's say yes. All right. Let's say we want to turn it into a shared namespace and then let our host 1.2 also get this namespace. We can do that by modify the NMIC and just turn it into shared namespace, and we'll click yes. What's cool about this is that normally you wouldn't be able to modify the NMIC property of your namespace, but we design it so that the users can modify the NMIC. You don't have to worry about creating a new namespace and copy your data over for the use of another system. You can just simply turn it into share and then simply attach it to another host machine. And there you go. You also get this 1 terabyte, exactly the same resource. So if you have written some data on the namespace, now your third host would be able to access the data. So that's namespace 0x2. Alright. So I'm not going to format namespace for now because we didn't actually read anything onto the namespace yet. So that's meaningless. We will keep that for now and go back. Alright, so you'll see that we have created 2 namespace. and we've used 5 virtual functions, and you can do that for each individual SSDs. And next we'll move on to the VF config page. This is where you can do the massive assignment of virtual functions. So remember I showed you that you can add VFs to your host ports one at a time by clicking on the add icon right here. Let me show you again. So you click this icon right here, you get one virtual function at a time. If that's too slow for you, you want to do a massive assignment, you can do it right here. So how exactly you do is you can select the SSDs you want to work with. Suppose we want to assign more virtual functions from SSD number 3 and 4 to our first 2 hosts. We can just adjust the number right here. So 1 each. And mind that only free virtual functions will show up right here. So any virtual functions that have been assigned to a host port wouldn't show up on this page. And we only allow the free virtual functions to be assigned. Okay, so we can just click on the apply button right here. So it tells you what it's going to do. And as estimate time is 12 seconds. So we'll click on yes. All right, it's done. So, yep. So we have successfully assigned virtual functions to our first 2 hosts. If we go back to the resource management and check out the host list, we will find that the virtual functions assigned to it has increased. Okay, so for virtual functions detach, we don't recommend users to detach the virtual functions too often, because detach a virtual function, unassign a virtual function from your host, you might have to reboot your host machines, and that's very annoying to do so. So we suggest users to keep the virtual functions assignment and adjust the resource by attaching and detaching the namespace. Alright, so the next page will be our port configuration. So this is where you can configure the host ports. So as you can see right here, we have turned a by 16 port into 4 by 4 host ports. So in total we get 5. And if you want to turn that back, you can do so. But what's important about this is that whenever you reconfigure your host ports, all the virtual functions that are previously assigned will be erased. So all the virtual functions will be back into the free virtual function pool. You will have to reassign the virtual functions again. So the next page will be monitor. You find all the monitor information, but since we don't have any connection to the host, you find no traffics. And this traffics, I suppose someone is running a test with the system, but I have no idea who is doing that, so let's forget about it. But you can see the ingress and egress traffic right here. So for system health, we have chassis temperature graph, device temperature graph, and power consumption graph, and fan speed graph. So it is quite easy to monitor whatever device or whatever component to find out if any issue happens to the system. For example, if a SSD temperature goes up really high, you know there are some kind of problem with the device, and you might want to stop the service of that device and check out what's going on with it. And for power consumption, so the gray line right here, the gray area right here is the sum of all power. So that says total. Perfect. We can click on that to take it out of the graph and click it again to add it back in. So if you only want to monitor, let's say slot 1, 2, 3, 4, you can just turn the other ones off. It shows you only the first 4 SSDs. Okay. Same thing here. Here. Alright. So that's pretty much all the basic functions you can do with Falcon 5208. So that's it for the video. Thank you for watching. I hope you enjoy it. And if you have any questions, please leave them at the comment section down below. And don't forget to hit that like button and turn on your notification. I'll see you next time. Bye bye.